any discussion on aircraft noise should really begin with giving you some background to what sound is. And sound is essentially a pressure wave. So we might look at a speaker here just to exemplify what's going on. So if we have a speaker, the speaker vibrates in and out. And as it vibrates, it causes the air to be compressed and then rarefied. So this compression and rarefication increases the pressure. So we get high pressure here and a low pressure here. So increase the pressure and decrease the pressure in the air. So these changes in pressure, they travel in a longitudinal wave from the noise source to the listener. So the sound is a longitudinal wave, sinusoidal, and if we hear a pure note, a pure tone, it has the same frequency. So we can have a high-pitched tone. So a high-pitched is caused by high frequency, and the note can be either loud or it can be soft. And whether it's loud or soft depends on the amplitude. So a low-pitched note would have a low frequency, and again the amplitude determines how loud it is. So sound is normally measured in decibels, sound pressure level, and it is the ratio of the pressure at the listener over a reference pressure, which is 2 by 10 to the power minus 5 pascals. However, human beings do not enjoy uniform response to sounds of the same intensity generated at different frequencies. And what that means is some frequencies or some pitches are just more annoying to us. So if you can just imagine a high-pitched sound and the irritation that causes to your ears. So the human hearing system responds to a wide range of frequencies, from about 20 hertz up to 20 kilohertz. And sound is generally in the 200 to 5K range, but mostly around here. I mean, normal for human speech. But frequencies, around 2K and upwards, they tend to annoy our ears. And the aviation authorities have said that if we have a noise level out here at 5 kilohertz, where we need to penalize that noise because it's at a frequency that really annoys us. So they have created a scale which penalizes frequencies that are in the annoying range. So the noise levels at which engine noises are measured in is the equivalent perceived noise decibel. So that's the unit we use for gas turbine engines. And just clarify it again, it's just penalizing those frequencies in those upper ranges that just annoy the human ear. There are other scales. There's the dBA scale and there's the dBc scale, which again allow for the annoyance at different frequencies. But for aircraft engines, we use the EPN dB scale. Now there has been improvement in the noise created by aircraft engines, and you can see, there's a gradual decline in the noise created by the engines. The noise is measured at particular places during the certification process. There's a noise at the approach reference location, and there's a flyover reference location, and there's a lateral reference location. So all these noise measurements are taken at these locations, and then it's put into a computer, and the equivalent perceived noise measurement is then calculated. So you can't actually measure the EPN dB. You just measure the normal sound, and then a computer algorithm will convert the decibels into the EPN dBs. Now, we did say that the noise was due to pressure variations, and in the engine there is a variance in pressure throughout the whole length of the engine. So we can see at departure, where we're at a high power setting, the noise is predominantly coming from the jet, or the nozzle. But there's still a significant contribution from the fan. And when we're coming into land, it'll be a low power setting, the fan is the most significant contributor to noise. Okay, so I just wanted to explain what equivalent perceived noise decibel was, and I hope you have some intuition into that.